Okay, in this question, you're given 3-month, you're given interest rates, PA means per annum per year. It's 3-month interest rate by the expressed per year. 3% in the U.S., 1% in Japan. Interest rates are always expressed as per year. So you're given the interest rates for dollars and yen. You're given the spot exchange rate for yen of 112.4 yen per dollar, and and the 3-month forward rate of 111.3 yen per dollar. That is how much you would have to pay in yen to receive $1. At any rate, you wish to borrow yen, but here they want you to synthetically borrow 100 million yen for 3 months without using the Japanese money market. Okay, that means without borrowing Japanese yen. So we're going to basically artificially borrow Japanese yen. In other words, we're going to construct a contract which has the same outcome as you would have had with borrowing yen. You're going to receive yen today. You're going to pay a known amount of yen 3 months from now. And your net cash flows in dollars will be zero both now and in 3 months. That's what we're looking for. Okay, and then also they want the implied interest rate on our yen loan. I mean, the actual interest rate is 1%. Since we're not borrowing or lending yen, we don't really need that in our calculation. So anyway, first, I just wrote the data down as usual. We're going to synthetically borrow 100 million yen. And that's, like I just said, we want the same outcome as borrowing yen. That is an inflow today of yen and an outflow in the future of yen. And net cash flows of dollars of zero. Here's the interest rates, 3% US, spot rate, forward rate. So we want to synthetically borrow 100 million yen for 3 months. Right? For 3 months. It's supposed to be a 3 anyway. So I could illustrate it, I suppose. We have four distinct animals, for lack of a better word. We have yen today. Put yen sub-zero. Put a little box around that. We have yen in the future. That's yen 3 months from now, representing cash flow 3 months from now of yen. We also have a cash flow of dollars 3 months from now. We want the net to be zero, but to get there, we're going to have to use dollars. We have dollars today times zero. So we can't use the Japanese money market. That's borrowing and lending of yen, converting today's yen into future yen or future yen into today's. We can't go from here to here either. We can't go like we would want to use an actual yen loan. We want to create an inflow today of what says 100 million yen. So we want the cash flow today, the net cash flow at time zero to be plus yen 100 million, right? And we want the net cash flow in the future, that's 3 months from now, to be, well, some negative. We have to pay back, replicating the repayment of the loan, so it's going to be in yen since it's supposed to be replicating a yen loan, but we don't know the amount yet. We have to figure that out. The way I'm going to do this, first I'm going to, I drew an arrow there. First I'm going to make sure I create that $100 million of yen. So first I'm going to, transaction number 1, I'm going to buy 100 million yen to create that inflow today as if you were borrowing. So buy 100 million yen. And that's not a forward contract, it's a spot contract. We want that inflow to come today. Spot contracts clear or settle within 48 hours, otherwise they're not called, otherwise they're not. But we can think of it as instantaneous. Most of them go through within less than a second. So we're going to buy 100 million yen spot and create that times zero cash inflow of 100 million yen. So the spot rate is, let's see, spot rate is 112.4. That's yen per dollar. And so how many dollars would you have to pay in order to get those 100 million yen with a spot contract? Well, it's 100 million divided by 112.4. If you're not sure whether to multiply or divide, just use a common sense thing. Here it's obviously if the price of a dollar is 112 yen, that means the dollar is worth, basically 1 yen is worth like a little bit less than 1 penny. And so 100 million yen is going to be roughly 1% of that in dollars. At any rate, yen, the dollar's worth more than yen, so we're going to divide by this large number. So we're going to buy 100 million divided by 112.4. That gives us, well, let's go ahead and write that down. 100 million yen divided by 112.4 yen per dollar. You can kind of see how the yen signs cancel out. You end up with dollars on top. So how many dollars are we paying for those yen? The spot contract, do that calculation. I believe you'll get 89, 680, according to my calculator. So that's transaction number 1. That creates that big inflow of yen at time 0, replicating the proceeds of the loan. Second transaction number 2, we want our net cash flow in dollars to be 0, otherwise we're not replicating a yen loan. So we've got an outflow of dollars equal to that amount. We want to create an inflow of dollars as well. So to do that, we have to draw down from the future. That is, we're going to borrow dollars. Of course, to replicate a foreign currency borrowing, you would borrow some other, or to replicate any borrowings of currency using another currency, you would borrow the other currency, what you're using to create the synthetic. So we're going to borrow dollars. How many, though? Well, you just saw it, 889. We want the net to be 0. So you've got an outflow of 889,000 at time 0 from the spot contract. Now we want an inflow of the same amount from dollar borrowing. So borrow using the U.S. money market. By the money market is simply a term that means the market for short-term debt. It's not a currency market. The currency market is called a foreign exchange market. At any rate, so we're going to borrow dollars. How many dollars? Yeah, we just said 889, 680. At the exchange, at the interest rate. Interest rates are exchange rates between current and future cash flows of the same currency. At the U.S. exchange rate, it's given as 3%. So that means our repayment in the future or I should say is what? Well, it's 889, 680 dollars. And it's going to be a future value of that. Using continuous compounding, we would multiply that by e to the RT. R is given 3%, so 0.03, and t is 3 months, which is 3/12 of a year, so times 3/12. So we do that calculation, and let's see, I'm getting, okay, 896, 377. Okay, so now since we're borrowing, we've got an $889,680 coming in at time 0, and that exactly offsets the same amount of dollars going out in order to buy the yen with a spot contract in transaction number 1. So now we end up with 0 cash flow at time 0 in dollars, but of course a positive 100 million in yen. Now 3 months from now we have this repayment. We want that to also be 0, so that we can replicate the yen loan, not a dollar loan. So we've got this outflow now, 896, and 3 months from now we want to offset that with an inflow of the same amount. So transaction number 3 is going to be, let's see, probably going to need to go on another page. Sorry about that. I'll just go ahead and list it here. So transaction number 3 is going to be to buy those same dollars forward. By the way, if you're buying one currency forward, you're automatically selling the other currency forward. So anyway, so we're going to buy that same number, so 896, 377. We're going to do it 3 months forward at the forward rate, which was given earlier. It's up here, way up here. Forward rate's 111.3, so let's use that forward rate for our forward contract, 111.3, and that's yen per dollar. Okay, now I do need another page. Oh, anyway, let's finish that off. If I'm buying $896, how many yen is that? Well, here we would multiply for each dollar is worth in the forward market 111.3, the forward exchange rate. So you multiply 896 times 111.3, and we get, or it's the same thing as selling dollars forward, or yen rather, forward. So how many yen are we selling? Do this calculation, we get 99 million, 99 million, oh dear, my webcam's not working very well. 99,766,000. The webcam I'm using, by the way, is very inexpensive. It's cheap. 766,804. There we go. So that is, with the forward contract, we're going to be paying 99,766,804 yen in order to receive 3 months from now the 896,377 dollars. Okay. So that's it. This ends up the 896 from transaction number 2, the repayment. Excuse me, repayment of the U.S. dollar loan, which is 896,377. We're receiving that same amount from the forward contract. So again, our net cash flow in dollars is going to be 0, both at time t equal 3 months and at time 0 from those three. So we've got this positive cash flow. We've got our at time 0 of 100 million yen and a negative cash flow of 99 million and change yen in the future. That looks like a really good deal, doesn't it? So let's see what these. So that's our. Well, let's illustrate a little bit more here. Net cash flows at time 0 are, what were they, from the spot purchase? The spot purchase of yen. We have plus 100 million yen at time 0. And the dollar, we have minus, from transaction number 1, we have minus 889 and change thousand dollars from transaction. I'm sorry, I'm looking at the wrong number. 889,680. Yeah, okay, that's the right number. Now from transaction number 2, we're receiving that same 889 and change $1,000. Also for number 2, we have a cash flow in the future. From transaction number 2, we're going to repay dollars, so it's minus. It's a negative cash flow. 896 we said. 377. And that takes care of transaction number 2. Transaction number 3, we're buying forward that same number. We're buying forward that same, so basically we're buying forward the repayment amount, dollars. And we're buying forward dollars, so we're selling forward the yen, so it's a minus yen cash flow of that 99,766 and so on. What's the interest rate? Well, we're using continuous compounding. It would be easier if we were using discrete compounding, but you know, you guys by now I think are pretty used to the continuous compounding. So we know that, you know, present value, some present amount cash flow, times e to the RT, right? It converts it into a future value. So, and I'm solving for R. I want the R. That's the synthetic interest rate. What is R? So rearranging, we get e to the RT equals, what is that, future value over present value? And how do I get the R out of the, or the RT actually, out of the exponent? Take the natural log of both sides is how you do that. So you take the log of e to the RT, which equals RT, of course. It's supposed to be an R. It's our synthetic R. And that's got to be equal. If you're taking the log of both sides, then you, on the right-hand side, you'd have log of future value over present value. And finally, getting the t out of there, we divide both sides by t, so R equals the natural log of future value over present value divided by t. In our case, that is, let's see, future value of our loan, it was that 99 thing, 99, 99, and these are both cash flows are in yen, 766, 804, and present value is the amount we borrowed, which is 100 million. Okay, that's future value. I should write that down. Anyways, natural log of that, 99, 766, 804 over 100. Okay, and then we said divided by t, so divided by, what was t? 3/12? So you're dividing by 3/12, that's like multiplying by 12/3, which is 4. So we take the log of this number first and then divide it by 4, basically. Or I'm sorry, multiply by 4. Because you're basically annualizing a 3-month rate by doing that. Dividing by 3/12 is the same as multiplying by 4, all right? Anyway, and when you do that, you end up with R equals what? Negative, of course, because the future value is less than the present value, so this implies a negative interest rate. Common sense, right? 0.93%. And of course, negative 0.93% is less than 1%, the Japanese money market rate of interest. And so you'd want to use the synthetic borrowing rather than the actual borrowing through the Japanese money market.